given this function here, that quotient, we're going to find dy dx. Now we could use the quotient rule, but let's instead use the general power rule by taking this factor here, that denominator, up to the top by changing the sign of the exponent. So we're going to write y as a product, as 2x plus 1 times that x squared minus 4, but to the negative 5. Now, I see a product here, so I'm going to use the product rule. So y prime will be the derivative of the first times the second, plus the first times the derivative of the second. So I'm going to use the product rule. So y prime will be the derivative of the first times the second, plus the first times the derivative of the second. Now, this factor here is the first, this factor here is the second, so let's see where this takes us. So y prime, the derivative of the first. Now, the derivative of the first, well, this is just linear, so that's just a 2. So I get a 2 times the second, which is the x squared minus 4 to the negative 5. There's the derivative of the first times the second, plus the first, which is the 2x plus 1, times the derivative of the second. Now the second, that's a power. So I'm going to bring the negative 5 down and then decrease it by 1, and be careful as I do that. So it's going to be, I'll bring the negative 5 down as a multiplier, x squared minus 4, now decrease it by 1. Negative 5 minus 1 is negative 6. Don't make it a negative 4, right? Then you're adding 1. So negative 5 decreased by 1 to negative 6. There's the derivative of the outside times the derivative of the inside. Now here's the inside. That derivative is going to be 2x. Right, there's the derivative. We just need to fix it up a bit. So let's see. We'll have y prime, not really much to do here. I'm going to write it as 2 times x squared minus 4 all to the negative 5. And then over here, this is all multiplication. I see a negative 5 times a 2x. I'm going to write that as a minus 10x times the 2x plus 1, and then the x squared minus 4 all to the negative 6. We can factor a bit here. What's common? I got a 2 here, and there's 2's here. Then I got this one here, x squared minus 4, negative 5 of them, x squared minus 4, negative 6 of them. Okay, so I got to be careful when I take these out. So I'm going to take it out like this. Y prime, I'm going to take out a 2, and then I always take out the smaller factor. So if this was a 5, just an actual 5 and a 6, I'd take out the 5 because there's fewer, right? 5 is smaller than 6. But we have negatives. So negative 6 is smaller than negative 5, so I'm going to take out x squared minus 4 to the negative 6. Now, if we do that, what's left? Well, look in the first one. The first one here, there was a 2, we took it out. There were negative 5 of these, and now I got negative 6, so there's really one more in here, right? This was a little bit tricky when you deal with these negative exponents, but I'm going to put it in here, and then we'll see what happens. Multiply it through. What do you get, just to be sure? Same base, so add the exponents. Negative 6 plus 1, negative 5. So if I'm taking out negative 6 to get back to 5, I have to have a 1 of them here. So you have to be careful with those negative exponents when you factor with them. And then, over here, there was negative 10. I took out a 2, so there's a negative 5 left, and the x, and the 2x plus 1. And what about here? Well, we took it out. So we've got our factored form. Now we're just going to fix up that inside. So y prime is 2 quantity x squared minus 4 to the negative 6. And what do we have in here? We've got an x squared minus 4, and then multiply through negative 10x squared and minus 5x. So this gives us y prime is 2 x squared minus 4 to the negative 6, and then we have x squared minus 10x squared is negative 9x squared, and then what? Minus 5x and a minus 4. Now it looks like we have it, but I'm going to do one more thing. You see here, I've got a negative, a negative, and a negative. I'm going to factor out that negative. Just factor out that negative. I'm going to pull it all the way out to the front. So I'm going to write this now as dy dx is negative 2 x squared minus 4 to the negative 6. And then, since I took out all those negatives, it'll change all those signs. How about 9x squared plus 5x plus 4. Okay, this is perfectly good. I could write my answer like this, or I suppose what I could do is I could go back in here and multiply all the way through here by negative 2. You know, I don't really think that's the best form, but I suppose one could write it like that. So if we did, it would be x squared minus 4 to the negative 6 times negative 18x squared minus 10x minus 8. I guess that's okay. Just too many negatives. Or what I could do, and I think I might do that with this form right here, is since I started over here, right, look back to the very beginning. I started with a quotient, positive exponents. I could drop that down to the denominator, and I could write that like this. dy dx is, if you drop that down, you're going to have an x squared minus 4 to the positive 6. And what's left in the top then is negative 2 times the quantity, 9x squared plus 5x plus 4. Okay, so that would work too. Actually, I think that's the preferable form. But, you know, when you put things into the computer, it might see something one way and not see it in another way. So any one of these three, I think, is good.